Hello students, welcome to EPG Pathshala. I am Monica Saini from Department of Anthropology, University of Delhi. Today, I am going to talk on module Analysis of Palm and Fingerprint under Forensic Anthropology paper. Through this module, students will gain an understanding of palm and fingerprints. They will be able to differentiate between particular patterns of palm and finger. They'll be able to analyze both palm and fingerprints. In addition, students will also be able to establish the possible matches and predict identity. Analyzing process is a careful examination of the print and identification of various patterns. It also analyzes sub-patterns, minutiae or rich characteristics established on the print, and then the comparison is made between the prints on the basis of those patterns encountered. If the patterns of both the prints are identical, then we proceed for further comparison in terms of rich details, and after analyzing, we are able to reveal the result that the print belongs to the same individual. Thus, analysis extracts the physical features of a print that can discriminate an individual from the other. And for this purpose, it is necessary to understand the characteristic feature of the palm and fingerprints. Rich counting, rich tracing, and various other techniques are employed to successfully analyze fingerprints. The palmar and plantar surface of human hand and foot differ from the covering that entails the rest of the body parts in terms of skin surface. The skin here is devoid of hairs and sebaceous glands, but sweat glands are numerous and abundant, and is entirely corrugated with narrow ridges. These ridges form definite pattern on the fingers or palm, and proper classification or analysis of these patterns help us to differentiate between prints. The high variability in the details of ridges in presence or absence of definite patterns and in the type of patterns help to individualize a person. It is said that no two persons can have exactly same prints even in the case of monozygotic twins within a cube of 4 nanometer of print. This is the reason behind its wider application in various domains of studies such as in personal identification, and thus it aids in forensic science in legal setting to reveal criminals, twin studies, studies of inheritance, studies of racial classification, and in many other studies of biological aspect. It is very important to understand how to differentiate between prints, or in other words, how to analyze a print, and for this purpose, we need to know the characteristics or pattern of ridges in prints of palms and fingers. Now we will be studying the characteristic feature of the fingerprints. The first feature is ridges. Ridges are elevated ribbing of the surface separated by grooves called sulci. Ridge skin along with palmar and plantar surface also occurs over the tip of the fingers. Ridges present numerous characteristics such as branching, interruption, and irregularities. Such characters are collectively termed as minutiae or ridge characteristics. Along the side of the ridge run single row of sweat gland ducts spaced at regular intervals. The distance between successive sweat pores on a ridge are about equal to the width of the ridge. Nowadays, various studies have been carried out on sweat pores as the variation they embrace in a unit area in terms of their pattern of distribution, the spacing between successive pores, alignment with reference to the axis of the ridge are sufficient to establish identification of an individual. The diagram is showing you the ridges on the fingers. Next, you will be studying the ridge characteristic. The ridges form definite pattern or designs on the terminal segment of the fingers and in palm and soles. These ridges pattern can be classified according to their general construction. Individual ridges show various irregularities of direction, discontinuities, and branching. Such characters are collectively termed as minutiae or ridge characteristic. There are various types of ridge characteristic such as core, ending ridge, short ridge, delta, hook, eye pattern, dot or island, crossover, bridge, enclosure, and special ridges. These are not usually grouped among minutiae but have a logical place in consideration of ridge characteristic. Incipient ridges are very narrow, frequently interrupted, and lie in the sulci. Nascent ridges lack pores, a feature that distinguish it from the typical ridges. Island ridges frequently show transverse constrictions, suggesting segmentation into units, each unit being associated with one sweat pore. The individual segments are sometimes completely disjoint and termed as islands. When two, three, or several such ridge unites, they are consolidated, then they are designated as short ridges. Ridge ending or end or termination can be understood as an abrupt stop in the course of ridge. Bifurcation or fork, it is a ridge that may branch forming a bifurcation or fork-like structure. Bifurcation is based on the consideration of one ridge branching rather than two ridge joining. If the two ridges were considered as coursing from the opposite direction, they are described as fusing instead of bifurcation. Eyelet, enclosure or leg, it may be described as rejoining of two branches after a short course. Crossover, the point of intersection of two ridges is a crossover. Hook or spur, it is a one short ridge branching from a long ridge. And the last ridge characteristic is a bridge. It is a short connecting ridge between two parallel running ridges. Next, you will be studying fixed point in fingerprints. First is point of core. Core is a pivotal feature in the interior of the pattern. The core may appear as a dot, an island, a short straight ridge, a rod, a circle or ellipse, a two interlocked hook, shaped ridge or staple. It is not the core as a whole, but the point of core is a landmark for ridge counting. The point of core is a centrally located core element. In case of a single rod core, the distal tip of the rod is the point of core. with uneven number of core rod in a core. It is the tip of the central one, and with even number, the central pair is treated as two-rod core. In case of hooked shaped ridge, the point of core lies at the junction with the distal recurvature of the staple. The figure is showing you the core and tri-radial point. The second fixed point in fingerprint is tri-radial point. It is located at the meeting point of three opposing ridge systems. A tri-radius is often described as a delta, but a distinction can be made between them. A delta is a triangular plot, whereas a tri-radius is represented by ridges forming its boundary. Thus, a tri-radius may be present if there is no true delta. The tri-radius has immense importance in fingerprint analysis. First, the three ridges extended from the tri-radius becomes the three radians. Second, the ridges extended from tri-radial point as type lines constitute the skeletal framework for print analysis. Third, tri-radius provides a landmark as tri-radial point for ridge counting and tracing, which ultimately forms the outer terminus of the line along which ridges are counted. Now, I'll be telling you some fundamentals of fingerprints. Pattern area. The area enclosed by the type lines by tracing the ridges extended from the tri-radius is denoted as pattern area. The pattern area represents only a section of the whole fingerprint. The region distal to the pattern area is the distal transverse system, and the region proximal to the pattern area is proximal transverse system. The figure is showing you the pattern area, where the pattern area is the highlighted portion. The second fundamental of fingerprint is radiant. The three rays traced on the print from the tri-radius by following the ridges are the three radiants. The three radiants are named according to their relation with the finger and with the pattern. The one passing through the digital border is the marginal radiant. The one in the marginal and distal relation to the pattern area is the distal pattern radiant, and the one in the proximal relation to the pattern area is the proximal pattern radiant. Figure is showing you the distal and proximal area with one representing point towards distal radiant, two towards proximal radiant, and three towards marginal radiant. The basic type of pattern in fingerprints. Galton classified three basic type of ridge patterns, that is arches, loops and whorls. But in the Henry system of classification, there are four main type of patterns: arches, loops, whorls and composites. First, I'll be talking about arch. The arch is the simplest of all fingerprint patterns. It is usually designated as pattern, but arch is actually patternless. In arch, ridges pass from one margin of the finger to the other with a slight bow distally. There is no tri-radius and the three radiants are not distinguishable. This type is designated as plain arch. Arch can also form a tent-like structure because of elevation of transversely crossing ridges defined as tented arch, which possess tri-radius located in or near the mid-axis of the digit. The figure is showing you plain arch and tented arch. Next, I'll be telling you about the loop. The loop is simpler in construction as compared to the whorl. It comprises only one tri-radius. Thus, the ridges curve around only one extremity of the pattern and form the opposite extremity. Ridges flows towards the margin of the finger. Thus, this extremity of the pattern may be described as open. If the loops open towards the ulnar side of the finger, it is referred as ulnar loop, whereas if it opens to the radial side, it is called radial loop. Loops may also be classified according to the size determined by the ridge count and according to the placing of the core with reference to the tri-radius. Thus, it can be narrow or broad loop, erect in line with the digital axis, or aligned obliquely or transversely to the digital axis. The figure is showing you pattern of ulnar loop and radial loop. The next pattern of fingerprint is whorl. The typical whorl has a generalized pattern which may be used as a standard of reference. It possesses true tri-radii and is distinguished by concentric pattern of ridges. The characteristic ridges form complete circuit around the core. Thus, whorl is a succession of rings or ellipses or spiral courses which is either in clockwise direction or in anti-clockwise direction. The periphery of the whorl determines the shape of the pattern area, which may be either circular or elliptical, and there are wide differences in the expense of pattern area of whorls. In whorls, the three topological zones or radiants are well defined and distinguished. The figure is showing you typical pattern of a whorl. Next pattern of fingerprint is composites. Composite represents the heterogeneous assemblage of patterns. These are compound patterns in which two or more basic patterns are combined in one pattern area. For example, a whorl and an ulnar loop present in a fingertip or in a pattern area form composite. In composite pattern, two or more tri-radii are present. Basically, there are four main types of composite encounter: central pocket loop, lateral pocket loop, twin loop, and accidental. A central pocket loop is a pattern immediate between a whorl and a loop. In this whorl of reduced size, lying in the interior of the pattern, like core, and then the ridges flows towards the margin of the finger. Thus, central pockets can be classified as ulnar or radial according to the direction of the open extremity of the loop. A lateral pocket loop is a composite type bearing two interlocked loops, and thus there are two cores. When lines traced from the two cores emerge on the same digital margin, such as radial or ulnar, the pattern is a lateral pocket loop. Twin loops and lateral pocket loops are closely similar structure as both are composed of interlocked loops. Thus, the distinction between them is of importance in the domain of identification and analysis of print. They differ in terms of coursing of ridges from the core of the two loops. When two lines course to opposite direction, one in ulnar margin and the other in radial margin, it becomes a twin loop. The last pattern of composite is accidental. Accidental are complex patterns formed by combination of two or more unrelated patterns such as whorl and a loop, a tented arch and a loop, triple loop, or any other pattern not assignable to the standard type. The figures are showing you different type of composites: central pocket loop, lateral pocket loop, twin loop, and accidentals. The last pattern of composite is accidental. Accidental are complex patterns formed by combination of two or more unrelated patterns such as whorl and a loop, a tented arch and a loop, triple loop, or any other pattern not assignable to the standard type. The table is showing you characteristic of three basic type of ridge pattern. In arch pattern, the core may be present, tri-radius is absent, radiants are not distinguished, and they have a straight ridges with a slight bow distally. In loop pattern, core is present, they have only one tri-radius, radiants are not delimited on the open side of the loop, and they have ridges curve around only one extremity of the pattern, forming the head of the loop. And in whorl, core is present, they have two tri-radius, radiants are well defined, and the ridges form concentric circuits around the core. Now, you will be studying how to analyze fingerprints. There are different steps. First step is identification of a particular pattern. Fingerprints are analyzed by using magnifying glass and a pointed pencil. Delicate uniqueness in terms of pattern of the print is recorded. The second step is counting of ridge. Ridge counting is performed to analyze a fingerprint. Ridge counting is defined as the number of ridges crossing or touching an imaginary line drawn between point of core and the tri-radius. The figures are showing you the ridge counting of various patterns. There are different rules for the counting of ridges. The first rule is point of core and tri-radius are not included in the count. If the imaginary line passes through the bifurcation, a ridge count of 2 is made at that point. If the imaginary line passes through an enclosure, a ridge count of 2 is made at that point, and if the imaginary line touches a dot, a ridge count of 1 is made at that point. Figure is showing you the counts of ridges in arch, loop and whorl. In arches, there is no tri-radius and ridge count is 0. In the given pattern of loop, it has one tri-radius and the number of ridge count is 13. In the whorl, it has two tri-radius and the ridge count on the left side is 17 and the number of ridge count on right side is 8. Now, I will talk about the calculation of pattern type indices. The pattern type indices are calculated on the basis of frequency distribution of the various finger patterns. There are basically three indices: Furuhata index, Denkemeier index and pattern intensity index. These indices are useful in the interpretation of fingerprint data and analysis of quantitative results, as it depicts the reciprocal relationship between loops, arches and whorls. The formula of Furuhata index is whorls divided by loops multiplied by 100, whereas Denkemeier index is computed as arches divided by whorls multiplied by 100, whereas formula of pattern intensity index is 2 multiplied by arches plus loops divided by n. Now I'll be telling you the pattern intensity. Patterns form a sequence of increasing pattern complexity which is expressed by counting the number of tri-radius present. According to the number of tri-radius, a finger can have a pattern intensity of 0 to 3. In cases of arch which lacks tri-radius, number 0 is assigned. The tented arch and the loop both are assigned number 1 as each has one tri-radius. Pattern size. It is determined by the ridge count from tri-radial point to the point of core. It is useful in inheritance studies. It is recorded as two integers representing the ridges count, one for that of the radical side of the pattern and one for the ulnar side. Thus, in an ulnar loop, it may be represented as 8 to 0, whereas for the radial loop, the reverse notation as 0 to 8. For the whorl, it will be like 4 to 8. Pattern form. Fingerprints can be analyzed in terms of pattern, as same patterns are variable with respect to the form of pattern area. Some patterns are elongated in the axis of the finger, whereas some are broad. Many a time, index of the pattern was generated, which indicates ratio of breadth to height of a pattern. Those prints intended for measurements of pattern should be taken with caution, and pressure should be even and gentle throughout the print, as breadth increases with added pressure. Now I'll tell you the different characteristic feature of palm print which can be used in the analysis of palm prints. The configuration of the palmar area is classifiable according to the general principle which govern the classification of fingerprints. In palm prints, to denote the location of various features, proximal, ulnar, distal, and radial are frequently used notation. Palmar surface is divisible into 6 topological units or configuration area, that is, hypothinner, thinner, and the 4 interdigital areas which are formulated individually. Each configuration area of the palm is recorded as a descriptive symbol which forms pattern formula in this order: hypothinner, thinner or interdigital first, interdigital second, interdigital third, and interdigital fourth. Palm area is interrupted by flexion creases which serve as a landmark in descriptive dermatoglyphics, but they are not the component of dermatoglyphics. Flexion creases are the lines of the palm. It represents the location of the attachment of the skin to the underlying structure. These are termed as white lines when viewed in prints. Major flexion creases across the palm are bracelet creases, metacarpophalangeal creases, radial longitudinal creases, distal transverse creases, and proximal transverse creases. These two figures are showing you the flexion creases and their configuration areas. In palms, tri-radii are distinguished in terms of their location as digital tri-radii and axial tri-radii. Characteristically, there are 4 digital tri-radii located at the base of digit, second, third, fourth, and fifth in proximal relation. They are named as A, B, C, and D in radio-ulnar sequence. The 4 main lines originating from digital tri-radii are capital A, capital B, capital C, and capital D in radio-ulnar sequence. Axial tri-radii is located at the proximal margin of the palm. A palm may have 1, 2, or 3 tri-radii, or rarely 1. Formulation of axial tri-radii in mainline formula is separated from the succeeding pattern formula by dashes. The most distally situated axial tri-radius near the center of the palm is T double dash, and one lies in the intermediate level is T single dash. In the absence of tri-radius, symbol 0 is used. Palm area can possess any pattern or configuration like fingerprints such as whorl, loop, and arches. As compared to the fingerprint whorls, palm print whorls have 3 tri-radii instead of 2. The symbol for the whorl is W. However, we add S as a superscript for whorls presenting spiral or double looped centers. For whorls having 8 or less than 8 ridges from the core to the nearest tri-radial point, we formulate the whorl as small by using the symbol small w instead of capital W. Palm print loops differ from the fingerprint loops in terms of direction of opening. A fingerprint loop has 2 directions, while a palm print loop has 3: ulnar side, radial side, carpal side, or proximal side. The symbol for loop is capital L, and superscript are added for the direction of opening, such as LU, LR, LC. Loops with 8 or less than 8 ridges are formulated as small l. Arches is designated by A with AU, AR, AC for ulnar, radial, and carpal direction respectively. Likewise, for tented arch as TU, TR, and TC. Open fills in which ridges are straight instead of arch are designated O, and vestiges as capital V. In case a configuration or palmar area bears 2 true patterns such as 2 ulnar loops, then it is formulated with 2 discrete configuration separated by a slant, and the distal configuration being recorded first, for example LU oblique LU. Complex configuration not assignable to the any of the types above characterized as capital Y. Now I will tell you the how to calculate the main line formula. A main line is traced according to the same rule as type lines in fingerprint. Main lines A, B, C and D originate from the respective digital tri-radii and line T from the axial tri-radii. Numbers are applied to a series of 14 intervals and points. Each traced line is described by the position in which it terminates. Suppose a line terminating in the second interdigital interval, it will be formulated by the number of that interval. After tracing the main lines, main line formula is formulated and it composed of the symbols of termination of lines recorded in the order capital D, capital C, capital B, capital A and capital T, followed by the respective patterns. Formulation of the patterns aid in the analysis of uniqueness of a palm print. Main line termination patterns in different configuration areas like hypothenar, thenar and interdigital areas, formulation of pattern and spatial formulation all aid in the analysis of uniqueness of a palm print. The figure is showing the tracing of main line from tri-radius to derive main line formula. The main line index is the sum of two numbers corresponding to the termination of main lines, that is capital A and capital D. The main line formula serves as an indication of the direction of palmar ridges. The termini of two of the main lines, that is capital A and capital D, are observed and the sums of those numbers are denoted as main line index. This will give an idea of palmar ridge transversality which may be of clinical significance. A low value for the index indicates vertical ridge alignment, whereas a high value reflects a tendency for the palmar ridge to be horizontal. Now, I will tell you about ridge counts. Ridge counting in palm is done according to the same principle applied in counting fingerprint ridges. The only difference is ridges of the palm are counted between two digital tri-radii. Counting is done by connecting both tri-radius with a straight line and the count excludes the ridge forming tri-radius. Ridge count between tri-radii small a and small b are referred as small a hyphen small b ridge count. which is most frequently used, dermatoglyphic analysis, particularly for medical purpose. Count between small b and small c is referred as small b hyphen small c ridge count, whereas count between small c and small d referred as small c hyphen small d ridge count. Pattern intensity expression. The pattern intensity of the palm can be expressed as the sum of all tri-radius present, ATD angle. The most widely used method for analysis of palm print is ATD angle. This angle is formed at the axial tri-radius, that is small t. The more distal the position of axial tri-radii in the palm, the larger the ATD angle. ATD angle is drawn from the digital tri-radius, that is small a, to the axial tri-radius, that is small t, and from the axial tri-radius to digital tri-radius, that is small d. The figure is showing you the ATD angle. Students, let us see what we have studied in this module. In a nutshell, it can be said that the true basis for analysis of fingerprints or palm prints is the comparison of their individual ridge characteristic. Analysis extracts the physical features of a print that can discriminate an individual from the other. Analysis of palm and fingerprint is very useful in personal identification, twin studies, studies of inheritance, studies of racial classification, and in many other studies of biological aspect. Nowadays, various automated techniques are employed to analyze the fingerprint and palm print, which requires pre-processing of image of print, then extraction of patterns or feature is performed, and after that verification is done. But the basis for analyzing the print lies in the understanding of the features of the print. Thank you.